Okay, the point of this little how-to video is plotting data points in an equation on the same graph in Google Sheets and charts. And I want to emphasize that we're plotting two different things, a set of individual data points and an equation, data from an equation or points from an equation. And we're doing them on the same graph so that we can compare those. Here's the idea. Suppose you have a math model, an equation basically, that gives you this number of bugs, we'll call it B, as a function of the initial number of bugs that you put in some container and the number of days they've been multiplying, which is, I guess, what bugs do. And let's say you have some reason to believe that this equation would describe that relationship. So if you put in the number 2 here for 2 days later, squared it, multiplied by 7, and added the initial number of bugs you had, that would tell you how many bugs you had after day 2. But not being satisfied with this, of course, you go out and actually measure in some container. So you do every 5 days, starting initially with the number of bugs you had, call that B0, let's say 10, and then every 5 days you measure the number of, you count basically, the number of bugs you have in those containers. Of course, after 50 days, the counting might take quite a while. But in any case, let's say you gathered this data. Here is our basic technique then for plotting this. The first thing we're going to do is create a dense list of synthetic points using the equation. So we just make in Google Sheets, and we'll show how to do this in just a moment. We create a data table with the day number and the number of bugs. And we start with 0, and we do it for each day, not every 5th day, but every single day. That's what I mean by a dense list of synthetic points. And we use the equation, this equation, to compute these numbers. So for example, on day 1, right here, we'd put a 1 in for D, square it, still get 1. 7 times 1 is 7, plus the initial number of bugs, which was 10. 7 plus 10 is 17, and that's where this is. If we came down to day, let's say 8, we could do 8 squared times 7 plus 10 would equal 458. So that's all these things are, and we'll see how to do that in just a moment. That gives us the expected number of bugs given our mathematical model of how nature works or whatever. The next thing we're going to do is add a column that goes with our number of bugs that we actually counted. And if we look here, we started with 10. On day 5, 181. If I jump back to the previous page here, you can see that on day 5 we had 181. On day 10 we had 733. So that's what we're going to do here. On day 5 we'll put in 181. On day 10 we'll put 733. And we'll leave the other entries blank, because we didn't count them every day. We only counted them every 5 days. The final thing we're going to do is plot both of these data columns here versus day number on the same Google chart. So here we go. We're switching to Google Charts now. So here's a spreadsheet I've made. I called it Graphing Data and Best Fit. We'll see what that means during the course of the year. And here's the data that I showed before, the same data table. Let's start by just making a chart containing this data, just so we can practice this. So we're going to say Insert Chart, and this comes up, and we're going to start by telling it what data to use in our chart. So I just click this little button and select not only the titles, not only the data, but the titles in the columns as well. And I say OK. And the next thing I want to do is tell it which kind of chart to use. And in this class, we are going to use scatter every single time. So don't even bother with those other things every single time. And you can see it's starting to plot it already. You can see it already. And since I included the title of the column here, it's giving me a little legend over here that tells me these blue dots represent the number of bugs counted. So then I move on to customize my chart. First of all, I'd like to put a title on it. So this would be, for example, bug count, count versus days elapsed days. We'll say elapsed days. And the legend we'll leave over on the right. Font, background, we don't care. Features, no. And now we're going to put labels on the horizontal and vertical axis. A graph without proper labels on the axes is useless. So we'll do horizontal first, and the title of that will be elapsed days. We'll put the symbol that we'll use in the equation, which is D, and the units, number of days, we'll put in parentheses. So there's three things listed on the axis: the name of the variable, the symbol we'll use in the equation, and in parentheses the units used for that particular thing. And this is all okay. And then we want to do the vertical, so we come up here and select vertical axis. You'll see, by the way, that it's already changed the thing that we just put. Now we'll do the vertical axis, and on the vertical axis, that would be bug count. We'll call that B, that variable B, and number of bugs is the units. It's just a count, that's all. All right, now we're good. Now we're going to keep on going down. We can change the number of grid lines we have here. Right now I have 5. Let's say that's on the vertical axis, 1, 2, 3, 4, 5. If I change this to, let's say, 10, I get a whole bunch more here. I don't really need that dense of a thing for here, so I'll just leave it as 5. And it's changing the number of horizontal lines here that go up the vertical axis, because I'm still on vertical axis here. If I wanted to change the number of vertical grid lines, I would go back to horizontal axis like this, and then I would come down here to this and change this. Right now the default is 5. I could make it 10 again. You can see that it would make it too dense. It's more than we want. We want 5. 5 is cool because then it counts in terms of numbers that we can understand. All right, we can change other things, but let's not bother with that. The color, these are blue dots. I want to make them red just to show that we can do that. We'll leave it at that. And I'll leave it big. I could make them smaller, but I don't want to do that. You'll see why in just a moment. I don't want to make them gigantic either, so 7 is okay. I can make them different shapes. For example, I can make them triangles or squares. Let's leave them as squares there. No, let's go back to circles. No, squares, good. Sorry. Okay, going on and on, none of this stuff. Trend lines, no, we're not going to do that. And now we say we're done. So we say insert, and we have our chart here, and it looks like this. That's what we expect. That simply shows the data that we took for 50 days. You can see that 50 winds up right about here, and we had about 17,000 bugs at that point. This doesn't really tell us if the model, the mathematical model, fits our actually measured data. So now we're going to, I'm just going to go up here and delete this chart. And we're going to do the process that I outlined before at the start of this video. I'm going to make another set of data bugs and counted. I'll put that down here. And over here, I'm going to put bugs predicted. And also, that's also going to be a B variable. Call it there. And we will start with the days, and I don't want to go by 5s now. I want to go by 1 day at a time all the way up to 50. So I'll start with 0. But instead of typing 1 and then 2, then 3, then 4, we can tell the spreadsheet to calculate the next one for us by typing an equal sign to start off with. And then I say take whatever was in the previous cell by just clicking it, and then add 1 to it. So I do that and hit enter. It'll say whatever this number is plus 1. Now I take this number and I drag it down till I get to, hello, go down, there we go. Till around 50, I'll just guess here. Oh, 51, pretty close. I'll erase that. So now I have 50, a column with numbers from 0 to 50 here. The bugs we actually counted, well, we counted 10 on the first day, so I'll put a 10 there. On the 5th day, we counted 181, so I'll copy that and paste it right here for 5. And on the 10th day, 733, and I probably should edit this out. You can see that I'm just going to keep going. 15, 20. Now we have this data in this column and the corresponding days at which the data was taken. Over here, we're going to put the predicted values for each day using the equation that we outlined before. That equation was this one. B equals the initial number of bugs plus 7 times the day number squared. So we go where we were. Right here. So I'm going to start here by saying equal, and now I'm going to put the initial number of bugs, which is 10, plus 7 times the day number, and I'm just going to take this by clicking on it, so I do it symbolically, and then I'm going to raise it to the second power by doing an up arrow and then a 2. Now I hit enter, and it will calculate that number for me. And now, just like before, I'm going to drag this down until we get to 50, and it will compute the predicted number of bugs at each one of those days. All right, now we have 2 columns, one of the actual data, one of the predicted values, and we'd like to make a chart that shows how those 2 things correspond over time. Here we go. Chart, insert, chart, there we go. Same thing as we did before. I'm selecting where the data lies, and I'm going to include the titles just so that we can get good labels on things. I'm going to go all the way down to 50. So I've selected that. Okay. Once again, we want to select a scatter chart because that's all we're going to be doing. Where is my scatter chart? Scatter, here we go. Scatter, you can see over here it's starting to plot already. You can barely see the data points underneath the line there. And now we're going to customize just like we did before, chart title. And now we'll say it's bug count versus predicted. That's what we're going to be looking at. The legend goes on the right. You can see that because we included those 2 titles of the columns, it's saying that the red dots are the predicted values and the blue dots are the actual counted values. We'll say more about that in a second. So the legend stays there. We go down axis, horizontal. The title of the axis, just like before, will be elapsed days, D for the symbol, and then number of days. So remember, there's always 3 things: the variable, the name of the variable, the symbol for the variable, and then the units that variable is measured in. And then we want the same thing for the vertical, so we put vertical, and vertical is bug count bugs, I guess just bugs, B, and this is number of bugs. Bugs, can't spell. All right, that looks good. We're going down. Number of grid lines looks roughly appropriate. Color. Okay, now we're going to get to a couple of things. First of all, we have different colors for the predicted values versus the actual counted values. We'll leave those colors different. I want to take the predicted values like this, which are in red, and I want to make that really small, like this. And the beauty of that is that now we can see the expected values versus how well the other values fall on those. And I'll say I'm done at this point. I could change the shape of things, but I'm not going to do that. I'm just going to leave it here. Let's move it over. I'll say insert, and we should get the chart up here. And we are, whoops, done. All right, so the predicted bugs are the little red ones. The counted bugs, you can see they're not exactly on the line, on the curve, which means that the number of bugs we counted more or less matches what we predicted, but not exactly, because that's what nature does. Everything is not exact. And that's the idea of how to take data that you've actually collected, individual data points, and compare it to a mathematical equation or a model. I'd like to thank A.J. Perrin for supplying me with this technique. I hadn't figured this out before, but he came up with this. See you later.